Hi, welcome to this lesson on trigonometry, trigonometric functions part 2. Okay, so let's have a look at question 2. On the set of axes below, the graph f of x equals cos 2x, with x between 0 degrees and 180 degrees, has been sketched. We want to sketch the graph of g of x, which is equal to 3 sine 2x, on that same interval. Okay, so this is the graph f of x that's been given. Let's just plot the points that we can see, right? So at 0 degrees, if I plug in cos of 2 times 0, that's cos of 0, which is 1. Okay, if I put in 45 degrees, 45 times 2 is 90, and cos of 90 degrees is 0. So that makes sense here. That's an x-intercept. At 90, 2 times 90 is 180, and the cos of 180 is negative 1. So that's the minimum point there. Okay, if I put in 135 times 2 is 270, and the cos of 270 is 0. So that makes sense. That's an x-intercept. And lastly, at the endpoint 180 degrees, cos of 2 times 180 is 360, and the cos of 360 is 1. All right, and if we think about cos 2x, the parameter that's affecting the parent graph cos x is that b value of 2 there in the front of x. And that just tells you that the period has changed. So instead of cos x having a period of 360 degrees, it has a period of 360 divided by 2, which is 180 degrees. And you can see in that 180 degrees, we have one full cosine wave. Okay, so now let's sketch the function g of x. So to do that, we're going to use some special points and our table function on our calculator. So go mode, table. Okay, so you're going to go 3 sine in brackets 2 alpha x, close brackets. Okay, and because I would like to make this graph as accurate as possible, I usually go in intervals of 30 degrees, okay? But you can try and stick to the intervals given to you if you just want to get those points out there as well. But as best practice, I always go 30 degrees. Okay, we're starting at 0, we're ending at 180, and my steps, I'll go in 30 degrees. Okay, so at 0 degrees, we have 0. So that is a x and y intercept. At 30 degrees, we have 2.598. So that's almost, so yeah, there's 3 here. So 2.598 will be somewhere up here. 2.598. Okay, so at 30 degrees and at 60 degrees, it'll be there. So let's go if I got intervals of 15 degrees. Yeah, 15, 30, 45, another 15 will give me 60, another 15 will be 75, then another 15 is 90. Okay, so I'm just going to partition up the graph into further points. It's 105 plus 15 is going to give you 120 degrees here, then 135. 15 will give you 150 degrees here. Then another 15 will give you 165 and 180. Awesome. Okay, so what I'm actually going to do is, because this jumps values, I think maybe 15 degrees might be more helpful here. So I'm going to keep everything else the same, and let's see if I go in integrals of 15. So at 15 degrees, it's 1.5, which is over here. So that's 1.5. Okay, at 30 degrees, we have 2.598, and then at 45 degrees, we have 3, which is going to be helpful. Okay, so 45 degrees, you have 3, and that would be the maximum. How do I know this? Okay, so look at this function here. What are the parameters affecting it? That's a equals 3 and b equals 2. So the b value of 2 tells us that this sine graph should complete a full wave in 360 divided by 2, 180 degrees. So we expect to see a full sine wave from 0 to 180 degrees. Then the a equals 3 tells us that the graph was vertically stretched by a factor of 3. So that means the standard range from negative 1 to 1 of sine x, the new range will be negative 3 to 3. So that's how I know this is going to be a maximum turning point, which is important. Okay. And then likening that with the symmetry of sine and cosines, we should see that 60 degrees, yes, that gives you that value back. 75 will come back to 1.5, and 90 degrees will come back to 0. Okay, so let's plug in those values there. So essentially, you're just matching up points using the table and then plotting them. Okay, 105 will give you negative 1.5, then negative 2.598, and then negative 3. Okay, so negative 1.5 is over here. Here's negative 3, so negative 2.598 is somewhere over here. Okay, so 105 was negative 1.5. Then 120 was negative 2.598. And then 135 degrees gives you that turning point there of negative 3. Okay, and then by symmetry, we should see those values being mirrored over. So 150, yeah, okay, so that is purely by symmetry here. And then 180 should give you 0 again. Okay, so now that we've got all those points, we can match it up. And look how nice our diagram comes out. Okay, so the more points you put in, the more accurate your sketch will be once you connect all the dots. Okay, it's a connect the dot game. Alright, so I can immediately see another intercept here, 90 degrees 0, and another one here, 180 degrees 0. So whenever you're drawing a graph in any kind of functions, not just trigonometry, it's always good to put very important points down. X-intercepts, Y-intercepts, turning points, asymptotes, all that good stuff on functions, you want to make sure you've got there. Alright, so that is the function g of x, and we can label it g. Calculate the values for when f of x equals g of x. So now look at this graph here. I see an intercept here and an intercept here. So the first one looks like it's going to be less than 15 degrees, and then other one looks like it's going to be bigger than 90 but less than 105 by the looks of it. Okay, so let's solve that. F of x is cos 2x, and g of x was 3 sine 2x. Okay, so the trigonometric equation, we need to solve it. Right now I see a sine of an angle and cos of an angle, so my mind instantly goes to tan. So if I divide both sides by cos 2x, I'll have 1 on the right left-hand side, and then 3 times sine 2x over cos 2x. Okay, but sine 2x over cos 2x is tan of 2x. So remember, tan of an angle is sine of the angle divided by cos of the angle. Alright, and then if I divide both sides by 3, I get tan of 2x equals 1/3. Okay, trigonometric equation time. Get the cast diagram out. Where is tan positive? In the first and third quadrants. Okay, but you'll only need one of the solutions when it comes to tan when you're working out a general solution. Okay, so reference angle, that's going to be tan inverse of 1/3. So let's go back to computation. Tan of 1/3, and that gives me 18.43 degrees. Okay, so that's the reference angle here. So I'm going to use the first quadrant as my general solution. X equals 18, not x, sorry, the angle here is 2x. Be very careful there. 18.4 degrees plus k times 180, where k is an integer. Okay, and then if I divide both sides by 2, I get x equals, so I divide by 2, 9.22 if I go to 2 decimal places. And don't forget to divide the 180 as well by 2, so that becomes 90 degrees now. Okay, so let's put in the solutions here. So if I put k equals 0, I get x equals 9.22 degrees. Is that within that given domain? Yes. K equals 1. Okay, if I put k equals 1, I'm going to get x equals 99.22 degrees. Is that in that interval? Yes. The moment I go greater than 1, so greater than equals to 2, I'm going to get values now that are going to be much bigger than 180 degrees. So it's not applicable. And if I take negative solutions, I'm also going to get negative values for x, and those will not be applicable in that given domain. Okay, so the two solutions should be these two. So 9.22 degrees. That makes sense, okay? And the other one was 99.22 degrees, which is over here. And again, that makes sense. Okay, so those are the x coordinates for the points of intersection. Lastly, for what values of x will f of x over g of x be undefined if x is in that interval? So let's write out what f of x over g of x is going to be. So that's going to be equal to cos 2x over 3 sine 2x. Okay, so when will that be undefined? Well, we have a fraction, and we know division by 0 is not allowed. So this is undefined on that interval if and only if the denominator 3 sine 2x equals 0. All right, but we've drawn 3 sine 2x, so we don't have to still go and work out the general solutions. So that's this graph in purple. So where's it 0? At 0 degrees, at 90 degrees, and 180 degrees, the y value is 0. Okay, so this is if and only if x is 0 degrees, 90 degrees, or 180 degrees. So those are the values of x that if you try and work out f of x over g of x, it will be undefined because you'll have division by 0. All right, that's how we would do these types of questions. I'll see you in the next one.